Hello everyone, in IQA series, let's discuss algebra problems from CAT 2022 second slot. This question is based mostly on linear equations. It says in an examination there were 75 questions, 3 marks were awarded for each correct answer, 1 mark was deducted for each wrong answer and 1 mark was awarded for each unattempted question. Ryan scored a total of 97 marks in the examination. If the number of unattempted question was higher than the number of attempted question, then the maximum number of correct answers that Ryan could have given in the examination is maximum number of correct answers, right? So let's say number of correct answers is equal to C, number of wrong answer is equal to W, and number of unattempted question is equal to U. Then this should be added up to 75, which is total number of questions. Now 3 marks are awarded for each correct answer and 1 mark is deducted for each wrong answer and 1 mark is awarded for each unattempted. This should be added up to 97. Other than these two, we are also have been given that number of unattempted question, which is U, was higher than number of attempted questions. So U is greater than number of attempted question means correct questions and wrong questions. So U is greater than C plus W. Now we can add U on both sides. We get 2U is greater than U plus C plus W. What is U plus C plus W? From equation 1 it's 75. So we can say U will be greater than equal to 37.5. So U must be greater than 37.5. Can we say minimum value of U must be 38 here? Number of unattempted question must be 38 in any scenario, not only in this one. So in that case, now let's try to add these two. If we add these two, we get 4C plus 2U will be equal to 172. Or 2C plus U will be equal to 86. Now, we need to maximize the value of C, right? Can we take the minimum value of U for that? So, what is the minimum value of U? It will be 38. So, 2C plus 38 is equal to 86 or 2C is equal to 48 or C is equal to 24. So here we get C is equal to 24, which is the maximum number of correct attempted questions, right? Now we can also verify this, like number of questions answered correctly is equal to 24. So 72 marks are awarded for that. Number of unattempted question is equal to 38. So 38 marks are awarded for that. Number of wrong answers would be, now 24 plus 38 is nothing but 62. So 75 minus 62, 13, and minus 13 marks have been awarded for that. So total marks would be equal to 72 plus 38 is 110 minus 13, which is 97. So that is our answer. Next question, it says if A and B are non-negative real numbers such that A plus 2B is equal to 6, then the average of the maximum and minimum possible value of A plus B is. So what do we know? A plus 2B is equal to 6. Now coefficient of A is 1, coefficient of B is 2. So if I want to maximize A plus B, what I can do is I will maximize the value with lesser coefficient. So coefficient of A is 1. So we need to take maximum. So maximum A will be 6 and B will be 0. So maximum A plus B will be equal to 6. If I want to minimize A plus B, then I should maximize the value of B because coefficient of B is 2 and coefficient of B is 1. So in that case we can take B is equal to 3 and A is equal to 0. So that will be 6. Now you can understand it with a different example also, like let's say 2x plus 3y is equal to 10. Now if I want to maximize or minimize the value of x plus y, what we can do here? We can take as coefficient of x is 2 and coefficient of y is 3. If you want to maximize x plus y, what you can do is take y minimum, because coefficient of y is bigger. So in that case, we will take the maximum value of x possible, which is 5, and y is 0. So this will give us 5. But if you want to minimize the value of x plus y, what you can do is take the maximum value of y and minimum value of x. So minimum value of x we can take 0, maximum value of y will be 10 by 3. So this gives us minimum value of x plus y. This is what we are doing here. Now question is, what is the average? So average will be equal to 6 plus 3 upon 2. 9 upon 2 is 4.5, which is option B. Next question, it says on day 1, there are 100 particles in a laboratory experiment. On day n, where n is greater than equal to 2, so second day onwards, 1 out of every n particles produces another particle. So on second day, every out of 2 particle, 1 new particle will be produced. Every 4 particle, total 2 particle will be produced. On day 3, out of every 3 particles, 1 particle will be produced. Out of every 30 particles, 10 new particles will be produced, and so on. If the total number of particles in laboratory experiment increases to 1000 on day m, then m equals. So let's talk about day 1, day 2, day 3, day 4 and day m, right? So on day 1 there are 100 particles. On day 2 what will happen? 100 plus 100 by 2, out of every 2 we are getting 1 new, so this will be a 150. On day 3, 150 plus, on day 3, 1 particle is generated out of every 3 particles. So 150 divided by 3, which is equal to 200. On day 4, it will be 200 plus 200 upon 4, which gives us 250. So on day m, what will be the total value? So you can see it's 100, 150, 200, 250. So there is an increment of 50 articles every day, right? There is an increment of 50 articles every day. So on day m, there are 1000 articles. So basically, can we say there is an increment of 900 particles? And for those 900, each day 50 particles are produced, 50 new particles are produced. So it will take 18 more days. So day 1 plus 18, it's day 19, which is option A. Next question, it says let R and C be real numbers. If R and minus R are the roots of 5x cube plus 6x square minus 10x plus 9 is equal to 0, then C equals, we need to find the value of C. So before we move forward solving this question, what do we know about polynomials and their root? So if there is a polynomial of degree 3 like this is equal to 0 and alpha, beta, gamma are the roots. So alpha, beta and gamma are the roots. We can say that alpha plus beta plus gamma will be equal to minus b upon a. Then taking 2 roots at a time, this will be equal to c by a, and then taking 3 roots at a time, alpha, beta, gamma, the product will be minus d by a. So now this is what will be very useful solving this question. So in this equation, let's say 2 roots are r and another root is alpha. What we can say, alpha plus r plus minus r will be equal to minus c by 5. R minus r cancelled out, or we can say alpha is equal to minus c by 5. Second, taking the product of this 2 at a time, alpha into r plus alpha into minus r plus r into minus r will be equal to minus 10 upon 5. So from here again, alpha r minus alpha r will be cancelled out and we get minus r square is equal to minus 2 or r is equal to 2. And then third, the product, if we take the product, what we can say is alpha into r into minus r will be equal to minus 9 upon 5. So basically what we are getting, alpha we are getting minus c by 5, r into r square is equal to 2, so minus r square is equal to minus 2 is equal to minus 9 upon 5. 5 will be cancelled out, minus minus plus, so we get c is equal to minus 9 by 2. So our answer is option A. Next question is based on functions. It says suppose for all integers x there are two functions f and g such that fx plus fx minus 1 is equal to 0 or this is equal to 1 and gx is equal to x square. If fx square minus x is equal to 5, then the value of sum of this and this is. So in recent year, I have seen functions problems in CAT are totally based on finding the pattern, and this question is very much similar to that. Now if I take x is equal to 0 here, I can say x0 plus f0 minus f minus 1 will be equal to 1, or if I take x is equal to 1 here, this will be equal to f1 plus f0 again 1, or similarly we can say f2 plus f1 will be equal to 1, f3 plus f2 will be equal to 1, and so on, right, and so on. Now let's see, f0 is common, so from here we get f1 is equal to f minus 1, and from these two we get f1 is common, so we get f0 is equal to f2, and next we get f2 is common, so we can say f1 is equal to f3, and then again next you will see that we are getting f2 is equal to f4. So what are we getting here? f0 is equal to f2, f2 is equal to f4, f1 is equal to f minus 1, f1 is equal to f3. So if we talk about only positive integers, you can say f1 will be equal to f3, which will be equal to f5, and every odd values of x, and f2 will be equal to f4, which will be equal to f6, and for every values of even x. Now next let's talk about this function fx square minus x is equal to 5. Now if I put fx is equal to 1, we get f1 square minus 1, which is equal to f0 is equal to 5. If I put x is equal to 2, then 2 square, 4 minus 2, it will be f2, which is equal to again 5. If I put x is equal to 3, so 3 square minus 3, f6 is equal to 5. So basically this is now again you can see is true. So f2 is equal to f4 is equal to f6, all of these values are equal to nothing but 5. Now let's solve this question. We need to find here f of g of 5 plus g of f of 5. So f of g of 5 means gx is equal to x square, so we need to find f25 here, plus now g of f5. What is g of f5? 5 is odd, so it should be equal to something here. Now how do we find odd values? We already know for even value of x, fx is equal to 5. What will be odd fx when x is odd? So let's come here, f1 plus f0 is equal to 1, right? So we know f0 is equal to 5. If this value is 5, then this value must be minus 4. Then only sum is 1. So f1, f3, f5, all the values will become minus 4. So this is g minus 4. f25 again, this will be minus 4 plus this will be 16. 4 square minus 4 square is 16. So overall our answer is 12. This was a theta problem where you need to fill the answer and your answer is 12. Next is a very interesting question based on logarithm. It says 4 minus the number of distinct integer values of n satisfying 4 minus log n base 2 upon 3 minus log n base 4 is less than 0. So what we can say, a by b is less than 0 if this happens only when a is greater than 0 and b is less than 0, or a is less than 0 and b is greater than 0. So let's try to consider the first case where 4 minus log n base 2 is greater than 0 and 3 minus log n base 4 is less than 0. So here we can say log n base 2 will be less than 4 and log n base 4 will be greater than 3. So n should be something so that we get it 4. If we take n is equal to 16, which is 2 to the power 4, then log 16 base 2 is exactly 4, and in the next one log 64 base 4 is exactly 3, because 16 is 2 to the power 4, 64 is 4 cube, and we know that log b to the power n to the base a is equal to n log b base a. This is the concept that we are using here. So here very easily we can say n will be less than 16 and here we can say n will be greater than 16. Now there is no intersection here. One says n is less than 16, means 15, 14, 13. Here it says n is greater than 64, means 65, 66. So there is no common value of n here. So let's consider the next possibility, next case, where we take 4 minus log n base 2 is less than 0 and 3 minus log n base 4 is less than 0. Not less than 0, it will be greater than 0. One is positive, other must be negative. If one is negative, other must be positive. Or here we can say log n base 2 must be greater than 4 and here it will be log n to the base 4 must be less than 3. So once again here we get n must be greater than 16 and n must be less than 64. So we get n is equal to 17, 18, 19 up to 63. So how many values are there? Up to 63, 16 values of n won't be taken, like 1, 2, 3 up to 16 we won't take. So what values do we take? How many values can we take for n? So 63 minus 16, 47 values are possible for n here. Again, this was a theta problem where you need to fill the answer, and the answer that you need to fill is 47. Next question, it says the number of integer solutions of the equation x square minus 10x to the power x square minus 3x minus 10 is equal to 1 is. So this is a very popular question. You must have seen these type of questions previously. This question has been asked in all type of competitive exams at least once. So to solve these type of questions, a very basic concept is required, which is if a to the power b is equal to 1, then 3 different cases are possible. When b is equal to 0, a is not equal to 0. Second, when a is equal to 1, and third, when a is equal to minus 1 and b is equal to even. So now let's try to apply this. So first case, where we have b is equal to 0, so x square minus 3x minus 10 should be equal to 0, or x square minus 5x plus 2x minus 10 is equal to 0, or if you take x common, this will become x minus 5. If you take 2 common, this will again become x minus 5 is equal to 0, and if we take x minus 5 common, we get x plus 2 is equal to 0. So one of these must be 0, so x is equal to 5 or x is equal to minus 2. So we got two integers values for x here. Now in the second case, where a is equal to 1, so x square minus 10 is equal to 1, or x square is equal to, this will become 11, right? So this will become 11, and in that case we get x is equal to plus minus root 11. So we don't need to consider this because it says number of integer solutions. So definitely we don't need to consider this. Now third case, where we need to take a is equal to minus 1. So x square minus 10 is equal to minus 1, or x square is equal to 9. So from here we get x is equal to 3, or x is equal to minus 3. Now we also need to check for these values of x square minus 3x minus 10 is even or not. So what we can do here, x is odd, so x square will become odd, minus 3 into x will also become odd minus odd is even, minus 10, so again even. So in that case we get this value as even. Similarly, for x is equal to minus 3, this will be 9, this will be plus 9. So 9 plus 9, 18 minus 10 is 8, which is again even. So all these values are true. So this value is true, this value is true, 5 is true, and minus 2 is true. So how many different values of x, integer values of x are possible? Answer is 4 values. Next question, it says consider the arithmetic progression 3, 7, 11 and so on, and let an denote the sum of first n terms of this progression. Then the value of 1 by 25 of summation of an when n is from 1 to 25. So first let's consider this arithmetic progression 3, 7, 11 and so on. So first term is 4 minus 1, second term is 8 minus 1, third term is 12 minus 1. So the nth term will be 4n minus 1. So sum of first n terms of this series, which is an, will be equal to summation of 4n minus 1, which will be equal to summation of n is n into n plus 1 by 2 and minus n, which will give us, so 2 cancelled out 2 times, 2n square plus 2n minus n, which is equal to 2n square plus n. Now again we need to find the summation of an. What will be summation of an? So 1 by 25 of summation of an will be equal to 1 by 25 summation of 2n square plus n, which will be equal to 1 by 25 times. Now summation of n square is nothing but n into n plus 1, 2n plus 1 upon 6, and summation of n is n into n plus 1 upon 2. Now we can put n is equal to 25 here, and what do we get? 1 by 25 times, this is 3 times, so this will be 25 into 26 into 51 divided by 3 plus 25 into 26 divided by 2. So we have 25 outside in denominator, so we can cancel out 25 from both sides. This will be 13 into 2 is 26, 17 into 3 is 51. So from there we get 17 into 6 is 102, carry 10, 17 into 2 34 plus 10 44 plus 13. So the value we are getting is 455, which is option C. Next question is a very interesting question based on quadratic expressions. It says let fx be a quadratic polynomial in x such that fx is greater than equal to 0 for all real numbers x. If f2 is equal to 0 and f4 is equal to 6, then f minus 2 is equal to. So this question could be solved in both ways, one a proper equation way or other proper graphical way. So let's try to solve it first with equation way. What we can see here, if fx is equal to ax square plus bx plus c, then as per given in the question, we can say f2 will be equal to 4a plus 2b plus c, which is equal to 0, first equation, and f4 will be equal to 16a plus 4b plus c is equal to 0. This is our second equation. So if you subtract this, what do we get? 12a plus 2b will be, this value is 6, will be 6, or we can say 6a plus b will be equal to 3. So this is our third equation. Now as fx is greater than equal to 0 or f2 is equal to 0, we can very simply say that the minimum value of this expression is achieved when x is equal to 2. And when do we get minimum value of an expression, quadratic expression, when a is greater than 0? That minimum value is achieved at minus b by 2, and that is equal to 2. So from here we can say b is equal to minus 4a. So let's put that here. 6a minus 4a will be equal to 3, or a will be equal to 3 by 2. If a is 3 by 2, we can say b will be equal to minus 6, putting here, and b is minus 6. We can also find out c. Let's put it here. This will become 3 by 2 into 4 is 6. This is minus 12. So 6 minus 12 is minus 6. So c must be 6 to get it 0. So now we get our expression fx is equal to ax square, which is 3 by 2x square, plus bx minus 6x plus c, which is plus 6, is equal to 0. So we can say f minus 2 will be equal to 3 by 2 into minus 2 square, which is plus 4, minus 6 into minus 2 will become 12 plus 6. This is not 0, that is a mistake. So this will be 18 plus 6, which is equal to 24. So answer for this question is 24. Now let's discuss another way to solve this question. Now we know that minimum value, this fx is always greater than equal to 0, and the minimum value of f2 is equal to 0. In that case, can we say there will be only one root of this equation, because f2 is equal to 0 means this graph is touching the y-axis. So one case, when we draw a graph like this, this is fx is equal to k into x square. Now as we are getting 0 at x is equal to 2, we need to move the graph 2 units to the right. Then only, so graph will be like this. This is 2. So here fx is equal to k into x minus 2 whole square, because of this. Now k into x minus 2 square, we know that for f4 it becomes 6. So we can say k into 4 minus 2 whole square is equal to 6. This is 4. We can say x is equal to 3 by 2. So now we got our function fx, which is equal to 3 by 2 times x minus 2 whole square. What we need to find now? We need to find f minus 2, which is equal to 3 by 2 times. This will be minus 2 minus 2, 4. So 4 into 4, which is equal to 16. So 3 by 2 into 16, that gives us 24 again. So you can use any of the approach, whichever looks comfortable to you.